This whole chapter is actually an extension of probability, but there are certain terminologies that we have to understand. Okay, so let me start with this small example to introduce all the different terms that we need. I've got a box here that has 4 red balls and 2 green balls. They tell us that we're going to select 3 balls at random without replacement. They're always going to define a certain term for us. And here they say that the number of green balls is going to be denoted by X. We first start thinking about what values X can take. X is the number of green balls, and it could take, say, 0, 1, and 2 green balls. Because minimum green is 0, maximum will be 2. So the range is usually unknown. We will have to determine that on our own. For every of these questions in this chapter, they will not tell you what is your range. Then they will start with, let's find this thing called a probability distribution. Probability distribution is actually trying to construct a table that will show you all possible outcomes of the variable alongside the respective probabilities. So you will have to list down your 0, 1, 2 and calculate the probabilities. We look at how to calculate this. I will just talk about the one with Px is 1. Px is 1 refers to you have 1 green and 2 red balls. So to calculate this, we will think of a tree. Let's say we have ball 1. The 2 possible choices are, I can go for green or red. So if we think of it from a tree perspective, what's the chance of getting that green? Green will be 2 out of 6 because you have 2 green balls. And then 4 out of 6 for the red. So for X to be 1, it's 1 green, 2 red. So next path that we want to think of as ball number 2 with further branch. I will just write in the necessary terms that we are going to require. So if my first one is green, then I know that the next path will be red. And getting a red on that next path will be red. There are 4 balls out of a total now of 5. Your number of balls will drop by 1. And I just draw one more branch. If you have green, red again, we are looking for this branch where now the probability of that is now 3/4. And that is how I obtained these first 3 terms. They are actually a result of having green, red, red. And remember, permutation for values on the tree is because this is trying to count the number of paths. Your number of paths can be GRR or any permutation of those 3 alphabets. 2 are repetitive, that's why there's 3 factorial over 2 factorial. You could do the same calculation at 0 and at 2. So suppose you have done all the calculation, you will present in a table structure, put 0, 1, 2 for your different X values. Probability will be written on that second row, but I need you to know that there's a difference in the X written. One is a capital letter, one is a small letter. Generally, when you write probability, this X here will be written as a capital letter in caps, where this is referring to a general variable. My variable is X and it can take on values 0, 1, 2, and so on. That small letter that you see is referring to, small letter, is referring to specific values of X. We are saying that the specific value that my variable can take is 0, 1, and 2. So this right side is that specific value, where I know that the specific value of 0, its probability is 1/5 counted above. When it's 1, it's 3/5. Last one will be 1/5. Okay, so this is what a probability distribution table is about. There's no difference from what we have done in the last few weeks except to present in this way. But we also need to know what is discrete random variable. Why is this chapter called this way? It's optional, but better for you to understand once. Random variable, the word random means my variable are outcomes of a random phenomenon. Random phenomenon means, for example, in this question, the number of green balls that I can get is completely by chance. I cannot control. We have no control over what balls you're going to pick. Because this is random, so we call it a random variable. The other word is discrete. To understand discrete, it's better for us to understand the opposite first, it'll be better. So what is an example of a non-discrete variable? Non-discrete means it is a continuous variable, such as numbers in a range. When you have a number in a range of values, there is no break between any two numbers inside. Like if you choose 0 and 0.5, there will always be something in between, like there is a 0.25 and so on. You don't get break in between the numbers in the range of 0 to 1. This is called continuous. So the opposite of this will be discrete. Discrete means the values are all distinct and it's countable. You can count one by one, such as 0, 1, 2, like integer values is one kind of discrete variable. Okay, so questions in this chapter are all discrete. You're going to get one value by one value and so on. Okay, let's go on. Next one, page 2. Same example, but more things to explain. I'm going to show you what this is about first. Now, remember, we are taking 3 balls and the number of green balls is denoted by X. Can we think of it as the first time that you do these 3 balls, you check the number of green ball and we call it X1. Let's have X1 to be like the first try of you taking those 3 balls and you check for the number of green. Maybe the value is 1. I just list an example. For the second time that you do the same thing, the variable will now be written as X2. So subscripts refer to like the first try, the first attempt, second attempt, third attempt, and so on. You count the number of green ball, could be given as 0, we don't know the number. But you look at those 3 balls, we count the green, these are the possible values. And this goes on. I could keep doing this many, many times to get myself different numbers. These are called different experiments or different instances of that variable. This will lead us to what is the meaning of this first term called EX. E stands for expectation or expected value or mean. All of them refers to we are trying to check for the average of my variable. I talked about the formula first, then I linked back to this 1, 2, 3, 4, and so on. The formula for expectation is straightforward. You're going to take the X value of the variable, whatever X outcomes it could be, and you multiply it to its respective probability. Before we sum up, take X value, multiply to probability, and sum up. So what this actually means in context is that, remember I could do this first, second, third, and fourth time and so on. All these numbers, if I find the average of this, I want to get the average of all these numbers over a very, very long run. I expect this number to be that expectation. Expectation of X means the average of each try that you're trying to do over a long run. In terms of the values, we try to apply it to our probability distribution table. So with a table here like this, X multiply to probability. So you get 0 times 1/5. 1 times 3/5. 2 times 1/5. We just apply and follow the formula accordingly, and we add up all the numbers. It gives me 1. But in order to understand this better, you want to know why the formula is as such. Another word for this expectation is also called a weighted average. So what's the difference in meaning behind weighted average versus average? If I'm purely finding the average of x, which is 0, 1, 2, what we would have done will be, you will just take 0 plus 1 plus 2 and you divide by 3. This is a normal average. But the meaning of weighted average is, for example, here we see that 1 has a higher probability. So if there is a higher chance that 1 may appear, I expect to give a larger proportion to 1 when I calculate the average. So you think of it as you give more weight to the value 1 versus less weight to the value 0 and 2. That's why we take the probability and you multiply to the number. A larger probability means this number is more likely to be your average. Okay, so we take probability times the value. If you sum up, it will give you that weighted average. Then they may change the variable. So it can also be, say, x squared. If it's x squared inside, it means that you are trying to find the average of x squared value. It's not x anymore. You're going to square each of the x values. So the only difference is, instead of x, you will see an x squared appearing. Probability is unchanged. You keep the same probability. So this will look like 0 squared times 1/5, 1 squared 3/5, and then 2 squared times 1/5, which will give me this number 1.4. They may change it to any other variable that they want. It could be, say, a modulus as well. Again, just remember the only difference is on this left-hand side. All the rest stays the same. So you're going to replace the x to your 0, to your 1, to your 2, and maintain the multiplication to your different probabilities. Okay, that will give you that expectation. Okay, one last phrase, which is variance. Let me talk about the formula first, then we think about what it really represents. Variance is done with a fixed formula here. You want to remember it with this formula more than the definition. In definition, they won't generally test, but they will always have this formula. The difference in the two expectation is you note the position of the square. The first term, the square is on x. The second term, the square is outside the expectation. Then standard deviation refers to square root of the variance. It's a fixed definition. Can we find this value first before I talk about what it represents? So this first term with the ex squared is referring to this value with the 1.4. The second value on the right is the expectation square, which is the 1 squared. So this value is, therefore, we take 1.4 and I subtract 1 squared. We will get this number 0.4. So what is the meaning of 0.4? What is variance? Okay, very broadly, we can think of it as this diagram. So let's say you have got different x values appearing. I currently know that the expectation is the value 1, which means this is on average. I know that we are going to get the value 1. So variance can be thought of as it's trying to measure the spread for the values of your variable with respect to the mean. Meaning you take your plus and minus 0.4 to the left and right. I expect that over many rounds, if I go and check the average, my values are likely to be in this range. With a very high chance, I expect the values of my x to be lying between, say, 0.4 to 0.6 to your 1.4. Variance is always trying to check for the spread. And spread is with respect to the average, the mean value, towards the left and towards right. Okay, but you don't need to really know this. What you need to know is the definition of variance in this format, the formula, and also what is standard deviation. It is the square root of your variance.